Hello everyone. So the clock has just struck 2 o'clock for those of us here in the UK. So first of all, I'd just like to say welcome to our first ever Circadian Mental Health Network Early Career Researcher webinar. Hopefully this is just the first of many because we have a fantastic lineup of speakers today and we've had quite a few ECRs very keen to present their research. So hopefully we'll be able to welcome you guys back very soon for another one of these. So thank you so much for joining us today. We have quite a lot to get through, so I'm going to just hand it straight on over to our first speaker. The speakers are going to chat for about 10 minutes and then we'll have a 5-minute kind of Q&A. There is a Q&A option to use within the webinar. You can also use the chat as well. If you're having any issues with sounds, if anybody's having problems with seeing screens, please let us know in the chat as well. So just stop sharing there. So I would like to introduce you to our first speaker, Dr. Catia Oliveira. She is from the University of York, working as a research associate, and her research focuses primarily on typical and atypical development in children, looking at that interplay between language, sleep, attention, memory, as well as mental health. So I'm going to hand it straight on over to Catia as our first speaker.
Thank you so much, Amy. So hi, everyone. Thank you so much for joining the event and Amy for organizing it. And today I'm going to be talking about the effect of early sleep in the preschool years on later vocabulary, academic achievement, and mental health. So I don't think it is a requirement for me to spend a lot of time convincing you that sleep is important. So I'm going to skip that and focus on why early sleep is a particularly interesting time span. So we know that sleep in the early years is quite different from later on, where it's quite a dynamic process that is characterized by this kind of period of transition where the baby initially divides their sleep between daytime and nighttime sleep, and then gradually consolidates it into nighttime sleep only, with potentially some napping, with some very big individual differences in adulthood. And we know that there is some evidence that suggests that these sleep characteristics that emerge in infancy may persist throughout childhood and adolescence, but there's quite a lot of literature focusing on concurrent sleep, but longitudinal research is quite limited. So we know that approximately 10 to 29% of infants and children under the age of 5 have difficulties with sleep. So this is quite an important issue with a high prevalence. And more importantly, is not just that children are experience these sleep difficulties in isolation, but that these sleep difficulties then have repercussions, not only for the child's development, but also for the parents and the family environment as a whole. So like I said, longitudinal studies are quite limited. When they follow up, they tend to be in terms of a very short time span, and they tend to focus only on a very narrow set of outcomes. So what we wanted to do here was to expand this and tap into kind of more real world outcomes in later childhood and adolescence. So to do this, obviously, it would be too hard to collect this data. So what we did was use the Avon longitudinal study of parents and children. So I will refer to it as the ALSPAC dataset. And this dataset basically started in the 90s, following the lives of children that were born between April 91 and December 92. And they are commonly referred to as the children of the 90s. This is a very cool data set. They have tremendous amounts of data. And even though, as you can see in these graphs, there's been some attrition across time, the number of participants is still quite high. And now there's data on the children of the 90s as well, on all the children of the 90s. So you can have a look into various generations across time. So for this project in specific, because we were interested in preschool sleep, we wanted to look at the sleep measures. We also looked at vocabulary, the majority of them measures through the Wechsler. Mental health, we used 2 different outcomes. A more screening tool, the strengths and difficulties questionnaire that looks at various symptoms, for example, emotion, conduct problems, hyperactivity, peer relation problems, etc. And another one that is more close to the DSM-4 and 5 that uses more diagnostic criteria. So the DOBA, and we focused only on anxiety and depression here. We also looked at outcomes in terms of schooling, both in terms of school entry and as well as at the end of kids stage 1, 2, 3, and 4. And to make sure that there wasn't a third variable that would explain this link between sleep and later outcomes, we also controlled for important variables such as sex, ethnicity, maternal education, household income, temperament, nonverbal IQ, amongst many others. So just to give you an overview of how we structured this analysis, we started first with exploratory factor analysis, but because we wanted to understand what sleep factors we were actually tapping into, because sleep is not a unified construct. At least that is what our data suggests. So coming from this data, we had variables tapping into sleep routine, as well as behaviors around and during bedtime, as well as night awakenings and bedtime and wake-up time. So what we found was that across time, the factor 1 seems to be tapping into sleep quality, so measures that tap it more into how infants are experiencing sleep and their ability to initiate and maintain sleep. And also the second factor tapping into sleep timing, so more related to when the child goes to bed and wakes up. We then used these 2 factors and fitted them separately in a growth mixture model. So what this model does, even though it seems quite complicated, is making sure that it identifies multiple unobserved populations in the subpopulations in the population we are studying. So if you look at this distribution here that is in the graph, what it would do is that it would identify that there's likely 2 trajectories across time, one that is quite stable and one that is improving across time. So this not only allows us to describe the change between this in each trajectory, but also compare the changes between those trajectories as well. So fitting this model to sleep quality, what we found was that, with better sleep quality in this graph being the more negative, was that there were 4 different profiles. One of them, the one at the bottom, being the ones that are the majority of the children, being the persistently good sleepers. So this is the children that I think most parents would like to have in their home because they sleep quite well. And then there's the ones at the top in purple that are the persistently poor sleepers, that are the profile that maintains their poor sleep across time. And then these profiles in the middle that are the least frequent, but also the ones that change the most. So the green one, the ones that we call the resolved poor sleepers, because they start out with being quite poor sleepers, but then improve quite substantially, and the opposite pattern for the increasingly poor sleepers. Now turning to sleep timings, we find this profile where there's the majority of people, children in this case, fit in these average sleep timings. And then there's 2 more extreme profiles, the ones at the top being the delayed sleep timings, the ones that go to bed quite early, quite late and wake up quite late and go to bed quite late, and the ones at the bottom with the opposite pattern. So now using this trajectories that we identified to predict later mental health, I'm going to orient you to the graph because I'm going to present this style in the rest of the analysis. So at the top, we have anxiety, whether or not they meet a diagnosis for anxiety, so either 1 or 0. And this is scored as probability. So the probability of meeting a diagnosis for anxiety at 7 years, 10 years, 13 years, and 15 years. In the middle for depression, and at the bottom for the SDQ. So the SDQ scores, the highest it is, the more at risk you are. So what we see here, and because I oriented the graph in a way that the worst sleep trajectories were the ones to the right, we see that the ones with the persistently poor sleepers or the increasingly poor sleepers are the ones more likely to have a diagnosis of anxiety across time, as well as for depression. They also score more highly on the SDQ at 6 years, but they change the most. So this is the SDQ slope. So the rate of change across time, they do change the most, which is positive. But if you plot the SDQ slopes, they really never catch up to the other ones, at least until up to the 16 years. It may be that they catch up later on. Turning now to academics and vocabulary, what we see here is the same pattern where they score lower on school readiness at the end of Key Stage 1 and on GCSEs, as well as on vocabulary at 49 months, 8 years, and 15 years. So it seems that if you have poorer sleep quality, you are at higher risk of having mental health issues and vocabulary and academic achievement. Turning now to sleep timings, I oriented in the same way. So early sleep timings to the left, in the middle average sleep timings, and to the right delayed sleep timings. And this is quite in line with the adolescent literature, where more extreme patterns of sleep timings are associated with worse anxiety, for the depression only at certain time points that is the case, but it is still, for example, at 10 years, they are still at higher risk of having a diagnosis of depression. And for the SDQ, the pattern is even more evident. So if you have this delayed sleep pattern, you're at higher risk, and then the early sleep timings are kind of in this intermediate profile. Again, the ones that have more extreme change the most, but they don't really catch up. Turning to sleep timings and vocabulary and academic achievement, what we see is that the early sleep timings are faring as well as the average sleep timings. In this case, only the delayed profile is a risk factor. So the delayed sleep timings are always underperforming in terms of academics, and also at higher risk for vocabulary. And this has been, like I said before, these models have been controlled for a lot of the variables that could be potentially confounding variables here. So just in conclusion, most children show adequate sleep timings and quality, which is quite positive. And we see that even when we control for key variables, early sleep is still important for later mental health, vocabulary, and academic achievement, with those that they show consistently or increasingly poorer quality, faring the worst in terms of vocabulary, academic achievement, and mental health, but also those that show more extreme sleep timings are also at risk of showing this also worse outcomes. So I just want to thank both Lisa, Amy Atkinson, Michelle St. Clair, and Gareth Gaskell that were the PIs on this project, and everyone else that has contributed to this project in any way, in meetings and so on, and also the children of the 90s, without whom this project would have been possible. Thank you so much. I don't know if I should stop sharing or if I will need them for any of the questions, but
I'd leave your slides up just now, Catia, so that in case there's any very specific questions about some of your things, you can always jump back. So it looks like we have a hand up, so I'm going to just let Sarania ask your question.
Hi, thank you. That was a great presentation, very useful for today, very relevant to the times of today. I just have a very interesting question, or more like a thought to put out. I think it would have been, of course, this study was done in the 90s and we might not have the data now, but it would be really useful to know what screen use time was like in the 90s as opposed to today, and how that would influence the results as in the 90s as opposed to the children of today longitudinally would be something for nice discussion.
Can I just ask a clarification question? Do you mean in terms of questionnaire? What kind of questions they asked for the sleep?
No, I'm saying that the children of today are much more exposed to screen use time.
Oh, yes. I apologize. Yes.
So that would be a great variable that would change the way the results are presented as well, I think.
Yes.
Media exposure and things like that, that probably has a significant effect on sleep quality and sleep duration. Yeah, just more like a thought than
yes, of course. Yes, that's a very interesting question. I have been doing some work with the born in Bradford data. We haven't finalized that, so I can't speak too much to that. But it's much more recent. It started in 2006, if I'm not mistaken. But yeah, it's still a kind of the empirical question of whether screen time would be as important in preschool years. I would very much be interested in knowing if that is the case. I'm assuming some parents may use screen to help children self-soothe, and that it would be potentially an interesting aspect for sure. Yeah, I don't know too much about that, but yeah, thank you so much. Yeah, for sure.
You're very welcome. Thank you.
Okay, we have another question from Jake.
Hey, thanks for the great talk. I'm just wondering whether you had the opportunity or whether you've actually looked at the impact of sleep timing variability in regards to some of your analysis. So, like, for example, waking up at 7 a.m. every day of the week, as opposed to waking up at some random time every day.
Yeah, that's a great question. I think it is a very interesting one, but given the type of question that we had, yeah, it was just I think the question was in the last 2 weeks. Yeah, in the last 2 weeks, what is the typical bedtime or something like that? It wasn't a sleep diary, for example, that would allow us to capture this more nuanced information. But I know that there's been some work looking at, for example, actigraphy, and that would be excellent. But I'm not sure if there's any longitudinal data set of this magnitude that has that information. But yeah, I would expect that, yeah, the variability would be very predictive for sure.
Okay, brilliant. Thank you.
Thank you so much.
Fantastic. I think we have time for one more burning question if anybody has one. So I'll just give you a moment to have a little think.
Yes, there's a question in the question and answer. Sorry.
Oh, yeah, sorry, this is a turnaround there.
Yeah, I can respond to it because I've just seen it. Whether there were sex differences in the analysis. I have considered sex not in this project. I have only looked at it as a covariate, but when I looked at the initial project that was looking at sleep longitudinally from 18 months to 9 years, because we were interested in the stability of across time, we only found sex differences for sleep timings where males, if I'm not mistaken, please look at the paper for that. Once it's published, I can share it. But I think males were more likely to go earlier to bed and be earlier to bed and early to rise than females, but I may be misremembering, but that's what I think what we found.
Great, fantastic. Thank you very much, Catia. That was an absolutely fantastic talk. So if you could just stop sharing screen and we will move on straight on to our second speaker. So our second speaker is Dr. Raahat Manrai from the University of Edinburgh. She is currently working on the Ambient BD project, which is looking into sleep, circadian rhythms and other functional outcomes in bipolar disorder over an 18-month period. But our main focus is also to make sure there is inclusion of lived experience within scientific research. So I'll hand it right on over to Raahat. Sorry, Raahat, you are on mute.
Sorry. Are you able to see my screen?
Yes, we can.
Oh, that's perfect. So hello, everyone. My name is Raahat, and I am a postdoc at the University of Edinburgh. And as Amy said, I am working on the Ambient BD project, which aims to understand sleep, circadian rhythms, and other functional outcomes in people with bipolar. My current presentation really focuses on using lived experience within sleep and circadian research. So I will be primarily discussing some results and highlights from an upcoming scoping review that a few researchers from my team and I conducted, along with certain implications on how we ECRs can actually include lived experience in different co-production or participatory methodologies within sleep and circadian research. So just to discuss the contents of this talk today, I'll be briefly dividing it into two bits, where one of them would be scoping review. I don't want to go too much deep into it as the paper is in review and might come out soon, but I would like to give some context to the latter half of the talk, which is more so about the guidelines on how we can include co-production or any other participatory methods within sleep research. So first talking about the scoping review, that's basically a small kind of paper that we wrote on use of co-production methodologies within sleep and circadian research to really just scope out what has previously been done and how many studies have actually used co-production or any other participatory methodology in their kind of research process or outcomes. So just giving an introduction, since I've mentioned the word co-production a few times right now. So co-production really refers to the process of collaboration, broadly defined collaboration within researchers and the wider community. That could be stakeholders, that could be clinicians, policymakers, care workers, or parents in case of children, young people, or children, young people themselves. It has been used in different terminologies in different parts or different types of research. Some people call it PPI, some people call it participatory action research. Some people could also just call advisory consultations or advisory groups. For this specific paper, we've used the term of co-production because we really wanted to focus on the collaboration or the co-design element between the researchers and the wider participants or the wider stakeholder community. So just giving an overview on why we focused on co-production within sleep. Sleep is quite an important emerging topic within wide research. That could be mental health, biological research, also a culmination of the two. And it's often measured, especially in combination with mental health measures, has been known to use successful innovative or digital technology, but co-production within sleep has a lower uptake. It is quite interesting to see that because mental health research is quite focusing or emphasizing on co-production methodologies at the moment. So it was quite interesting or fascinating to know why is there such a lack within sleep research, even though sleep is an important outcome in which a lot of mental health studies focus upon. So the aim of the review, as I mentioned, was to really synthesize existing literature on what co-production methodologies have been used in sleep and circadian research, or have they been used at all, and what those trends look like. Just giving a highlight of what these themes really led us to kind of discuss or conclude within the specific paper, that there was no focus on circadian research. All of the focus or all of the papers that were included in the study focused on sleep, but not on circadian, which is a huge gap within sleep and circadian literature. Co-production was used with wider stakeholders. As I said, stakeholders consisted of other research teams, policymakers, clinical staff, teachers, prison staff, children and young people themselves, and their caregivers. Another interesting finding was that there was a huge lack of clarity within what co-production is, so that it was really difficult to define what that element was for the individual papers that were included. A lot of them said that they included or they conducted a co-production or they conducted some lived experience input, but most of them just conducted interviews or like qualitative studies, which were really focused on people's experiences rather using those experiences within the research process. And I will focus a lot more in the on this specific element within the latter half of the presentation. It was also interesting to see that some of the papers which were included, they did mention doing some really deep co-production processes, but most of those processes were not published, which really showed like a publication bias within this whole process of like co-production research methodologies. So that's the reason why they could not really be included within the final findings of the paper as well. And one of the really important processes of co-production, which is conducting a feedback loop towards the end, was missing in all of the studies. So none of the research teams within the papers that were included, they conducted the whole process and went back to the stakeholders. So they did not do that, which is where there was no way to ensure the authenticity or the actual reflection of people's experiences within the research process. That was basically a whistle-stop tour, as I would say, of the paper that's about to come. And as I said, that I don't really want to go into a lot more details because the paper is about to come. And I really more so want to focus on how we can do co-production or how we can include any of the participatory action research methods within our scientific research process. So for the next part of the presentation, I would use a broader term, which is called PPI, which mainly includes different types of co-production that I mentioned. The PPI, or patient-public involvement and engagement, basically constructs or includes like a myriad of different methodologies, co-production being one of them. Others could be advisory panels or consultations, where you can conduct focus groups or a series of focus groups with people and ask them different questions and include those questions within your, or include their findings, experiences, results, reflections, whatever you want to call them, in your research process. It could also be peer research, where the members of your stakeholder community or people with lived experience are basically a part of your research group. You could train people to do that. You could already include people within your research group when you're conceptualizing this research. There's also some novel methods called citizen science, or also known as workshops, where you can train or conduct some like scientific methods with people, again, within a workshop, and help them to know, or help the researchers to know, the compliance, engagement, or adherence specific scientific technology. PPI also includes as like knowledge exchange and dissemination, which is, I would say, the most popular way of conducting it, where then you conduct like events like knowledge exchange, or get people from your stakeholder community to be co-authors, or they could also help you in kind of giving like a conference presentation, so on and so forth. So really helping your stakeholders to disseminate your findings in a really diverse manner. And collaborations. Collaborations is a way to really map out who your key stakeholders are. And I'll talk about it a bit more in the next slide, but it's also one of the ways you can include people with lived experience within the scientific process. So just talking about different stages of PPIE, it's basically a very elaborate process, which takes a huge amount of time and resources. Stage one of it is the mapping stage, where really you can do and scope out key organizations, key people, or even do like a priority setting exercise to really help you understand what are the needs of the community that you want to work with. Then that leads to collaboration, where you can develop a trusted relationship. You can maybe attend more workshops or attend key meetings, or get people to visit you to really know what you're doing. But it involves more active or like more proactive effort from the part of the research team to really make them feel included. This then leads to conceptualization. A lot of the times it is said that people start doing a lot of the PPIE work once the study has been conceptualized. But the actual way is to include people with lived experience or any sort of like stakeholders within the planning and conceptualization stage, which could really help you to know what data collection methods to use, how much are the timescales of the process, how to recruit people from diverse experiences and marginalized backgrounds, and so on and so forth. And they could also advise you on the specific methodologies you want to use in research. and then doing a feedback step. Now, the feedback loop is really important because often at times what we do is we collect all of the experiences and make decisions within the research community, within the research team, without actually going back to the stakeholders and asking them whether those decisions are reflective of their experience or not. And often if we don't do that, we're really excluding the people's experiences and reflections, and the whole exercise of conducting any sort of PPI is then futile. So just giving examples of PPIE work that I have done. So I'm currently working on the ambient BD project and conducting advisory consultations, regular advisory consultations with people with bipolar. And all of these discussions would then feed into the prospective study. So far, they've helped us in determining the research questions, functional and clinical outcomes. They've commented on our data collection methodologies. Coming in January, we will also start piloting different digital technologies that we'll be using within the prospective study. It is also helpful to know that people with lived experience helped to write the grant application for ambient BD. So we can really say that it is a co-produced project all in all. They will also be helping us with knowledge exchange and dissemination of the findings later on. And in my previous experience, I conducted peer research with care experienced young people with a history of developmental trauma. And I basically was trying to understand their mental health outcomes, how they form relationships with adults around them, starting from conducting advisory consultations, using those to set a research question and hypotheses, training them and facilitating them in asking questions to their peers, and really overlooking the whole interview process, which was young people interviewing young people essentially. And that was a part of my PhD. So these are the two big projects that I have been involved in, and I've been doing PPIE work in different ways. And all of the reflections so far have come up from these specific projects for me. So just to conclude, there are certain considerations that we really need to take. We need to ensure flexibility, because often at times we take certain decisions and then we don't want to move them. And that's not how co-production is done, because the reality for people with lived experience or any sort of like stakeholders look much different to what the researchers consider it to be. That could include language or use of jargon. That could include a lot of ethics processes, or maybe even where to conduct your research, so on and so forth. So it is really advisable to ensure as much flexibility as possible. It is also important to form trusted relationships. So it is helpful to have researchers, and especially in the collaboration element I was mentioning, to really have a trusted relationship with a specific organization. That does not just mean like approach that organization and do kind of your data collection and come back. There's always like a give and take that's involved, which leads to reciprocal efforts, where you need to make sure that people who are a part of your process, of that co-production process, also gain something. Transferable skills is definitely one of the biggest ones. And in both the projects, people have mentioned that, where it's helpful for them to be a part of these discussions, where they can learn more about their own experiences, meet other people with similar experiences as them, and have kind of like a sense of belongingness. And availability of time and resources. That is definitely one of the biggest ones, because as I said, doing any sort of participatory research involves a lot of time and resources, and due diligence should be given to them as such. So that was my talk, and here are my couple of references that I've used in the slides. I'm open to any questions. Thank you so much for listening to me. I'm going to stop sharing my screen so I can see everybody on it. But if you have any questions, I can put my screen up.
So thank you so much, Raahat. That was a fantastic talk. Unfortunately, we don't have time for questions at this point. But if anybody has any questions for Raahat, please put it in the Q&A. She'll see that and she can comment on your questions there. We're going to have to just move straight on into our next speaker. We have a lot to cover today. So thank you so much, Raahat. And we're going to move right on over to Chloe Roddis, who is a second-year PhD student from the University of Manchester, so quite an early career researcher, with an interest in light exposure and mental health. So just give us a little moment. We had to do this kind of like two-step process for sharing ahead of time before. So if you just give us a little sec and we'll see Chloe's slides, hopefully. Okay, maybe a three-step process, bear with us. And as I said, if you have any questions for Raahat, feel free to pop them in the chat. She will see them, or pop them in the Q&A and she can comment from there. So I'll hand it over to Chloe.
Perfect. I hope everyone can see them. Is that all okay? Perfect. So first of all, I'd like to just say thank you so much for inviting me to give this talk. My name is Chloe Roddis. I'm a second year PhD student at the University of Manchester. My supervisors are Dr. Nina Milosavljevic and Dr. Beatrice Bano-Otalora. My presentation today is going to be looking at my PhD research that's looking at investigating the impact of light on mood in everyday life. So basically, to start off, I'm going to ask you all the question, when do you feel you're happiest? So most of you might be thinking it's a sunny day rather than a gloomy day, but unfortunately, we don't really spend much time outside. And at least in Manchester, sunny days aren't very frequent. So basically, due to sort of working and living indoors, it means we spend around 90% of our time exposed to artificial lighting. And obviously due to sort of technology advancing, we have light at night, which is not what we'd have been experiencing in nature. And so the question is, are we actually getting the right light exposure? And according to sort of recent publications on recommendations for indoor lighting by Tim Brown and colleagues, it looks like the answer is no. So they basically suggest 250 melanopic lux in the day, 10 in the evening and 1 at night. But this is basically for physiology and sleep and wakefulness, which is extremely important. But whilst we basically agreed that, you know, empirically, we feel better on sunny days, scientists don't know what light recommendations are important for mood and emotional bias. And because we basically have this sort of control over lighting, we should be able to, you know, optimize actually the effects of it. So whether we need to minimize the negative or maximize the positive. And so we need to improve our understanding on this. And this is not only important for sort of future lighting, but also for improving the general well-being of the population. And so from science, you might already know that light therapy is working in conditions such as seasonal affective disorder and depression to relieve symptoms, but we know so little on the specific aspects of light. So the duration of the exposure, the intensity, the time of day, and how it's actually so important for the therapeutic effect. And therefore, we can't utilize the full potential of light therapy. So therefore, we know that it works, but how? So moving forward, it's essential for us to understand these biological mechanisms that are underlying how light impacts mood. And this is basically the core interest of our lab, to understand these biological mechanisms. And so we designed a study to look at this in humans. So we designed a naturalistic human study, and basically to try and be as objective and quantitative as possible. We designed it so that we'd got 3 main aspects that we think are pretty crucial for this design. So the first thing is that we used a gold standard Condor Act Loomis device, which measures light, but also melanopic EDI, which is basically a measurement for how much a light affects the non-visual system in humans. We've then got subjective mood questions to assess how the individual feels consciously, but more importantly, objective and validated mood tasks for the subconscious, which I'll tell you about a little bit later. And we've also got the objective measures for sleep and physiology through a Fitbit device. So basically, to help us look at how to measure these effects of light and mood in everyday life, this was what was done. And we collected data from 51 participants in summer and winter for 7 days. And then this is basically just the protocol down here. So from day 2 to day 7, they complete a sleep diary in the morning. They do the subjective mood questionnaires 5 times a day throughout the day, and the objective mood task completed in the evening, whilst also wearing both of these devices. And so the overarching question of this is, does light exposure impact mood in an everyday life setting? And empirically, this is yes, but obviously the real question is, can we actually capture that? And so specifically what we want to look at is, what are the impacts of acute light exposure on mood, but also what are the impacts of light history on mood? And obviously, as previously said, we want to look at this from both the subjective and objective angle. So we're really excited about this data set. I finished collecting the data in September, so now we're on to analysing. So although we don't have any sort of concrete answers, I just wanted to show a little bit of preliminary data. So basically, this basically shows what we measured with the Advanced Light Centre, which measures both melanopic EDI and photopic lux. And basically, this is just showing that across the days, there's a clear increase in light exposure sort of in the day, and there's next to no light exposure in the evening. And we also looked at this daily light exposure for all participants, where we can basically see that light exposure is mostly from 5 a.m. to 12 a.m. And we can see this significant sort of light at night, which might be due to artificial lighting. So then if we move on to the mood questionnaires, I'll do the subjective ones first, but for this, we basically asked individuals on a scale of 0 to 100, where is your current mood score for the following emotions? So sad to happy, stressed to relax. It's gone over my thing, so I actually can't see them once. But yeah, you know, you get the gist. And basically, for this, looking at sort of just 5 participants' data, which shows the data from sad to happy across the day. What we've got on average is that there's about like a 70 score for that, which is sort of suggesting that they are a happier cohort, which is what we'd expect to see in these healthy participants. But because this is only obviously in 5 participants, it's hard to, you know, draw any conclusions. So we're now looking at sort of the time of day effect on all the different moods that we've got on here, and then analysing the whole data set for that. And so then if we look at the emotion bias tasks, so you might be thinking, you know, how do we actually measure mood objectively? So we've been collaborating with Catherine Harmer's group from Oxford, and they use this emotional test battery, which is well validated. It's used for screening antidepressants and should be insensitive to a placebo effect. So it's used to measure essentially the core intrinsic values that we have of emotional bias. And we thought that it'd go well with the subjective measures because there's less chance of there being this variable emotion. And usually when they do these tasks, they have them in just one sitting. But what we did differently is to measure sort of across different days of the week. We split it. And so this is the first time these tasks have also been used in this way. So just to describe the tasks to you all. So the first one is the emotional categorization task. So for this, participants are given 40 different emotional adjectives. So for example, criminal, and then they've then got to say whether they would like or dislike to be associated with it. So we would expect people to say they would dislike to be associated with criminal for this one. We then move on to the emotional recall task, which a text box will appear, and the participants have to type in as many words as they can remember from that first task. And the last task is the emotional memory task. So they're again shown positive and negative words. Some of them will have been in the first task and some of them will be new. And they've got to basically say whether they were present or absent in that first task. And so if we're then looking at the data from this in 5 participants, basically what we wanted to see is if the tasks were actually performing as well as they usually do, and if they're still sensitive enough because we split them across different days. So if we basically look at, you know, the split per day and then the days combined for the categorization task, we've got a pretty similar there's not really much variation here. So if the blue is positive and the red is negative across the different days, there's not that much of a difference there. And again, when we combine the days, there's not much of a difference. For this, we'd expect this because, you know, people should be able to categorize positive and negative words. It should be relatively easy for them. And then for the recall task across the different days, again, there's some sort of variation going on here, but there's not like a clear pattern. But then with the days combined, we've got this slight increase in the positive words that people would recall. And then for the emotional memory task, again, there's not really a clear variation here, but there is this increase again of the positive words that they actually recall when the days are combined. And so what we're sort of seeing overall from this is, although there's, you know, we can't really draw any conclusions because there's only 5 participants, it's that it looks like it's still able to characterize whether, you know, there's a positive or negative bias when splitting it across different days. And so what's next? So we're very excited to have this data set, and obviously we're working on the analysis now. And what we basically want to look at is the correlations of acute light and mood. So this would be when they complete the mood task, what is their light exposure 30 minutes before they do that. And then for sort of light history and mood, it would be looking at the daily and weekly light exposure and how that might impact their mood scores. So yes, I would like to thank my supervisors, collaborators for all their help, and yeah, I would like to take any questions.
Thank you so much, Chloe. That was a fantastic talk. Yeah, we are open to a couple of questions. We have some time for that, so feel free to raise your hand, pop them in the chat, pop them in the Q&A. The world is your oyster for asking questions. Okay. Oh, a couple of questions coming in. So Siobhan, I think you've had your hand up first, so if you can just unmute.
Hi, thanks for a fantastic talk. I was just wondering if you included any questions about sleep in your questionnaire.
Yes, so obviously the mood questionnaires are very much a separate thing, but yeah, one of the main things that we did is we had the Fitbit, so that obviously is testing their sleep anyway.
Okay, right.
Objectively, but then each day, yeah, they fill in a sleep diary, and you know, throughout the day when they do their mood test, it asks them how sleepy they are as well. So yeah.
Thank you.
Great. And Jake.
Hey, yeah, thanks for a nice talk. Just a quick question about one of the devices that you're using. You said that there's like a light meter that kind of measures in some way the kind of activation of the non-visual kind of system. How does the device measure that activation?
So the light basically has 10 different light sensors in there. And yeah, there's some very clever programming that they've done in there to basically calculate this. So melanopic EDI, basically, I obviously described it very, very briefly, but it's basically the amount of light that impacts the non-visual system. But people are basically now understanding a lot more that there's a third photoreceptor, which are IPRGCs. So melanopic EDI is basically the amount of light that triggers this specific photoreceptor, which is then, you know, helping us answer the question, is it the specific kind of light? Like what specific kind of light is essential? So yeah, it's a complicated equation essentially.
Okay, yeah, so it's sort of like trained off of like some sort of previous data set, so it sort of knows roughly how much that light or the frequencies of the light is impacting the visual system based off something previous.
Yes, so it'd be like, so usually we would measure, there's like 2 different ways. So we would measure in either, you know, phototopic lux, which is how much it impacts cones, let's say, which is another photoreceptor, but then there's an equation that they then do with that to then help us understand melanopic EDI lux.
Brilliant, thank you.
Great, thank you so much everyone for your questions. as I'd mentioned before, you can pop things in the Q&A and the speakers can see them and comment on them as we go through as well. So thank you very much, Chloe. We're now going to move on to our next speaker, who is joining us from all the way on the other side of the world from where I'm currently sitting. So apologies for any disruptions to your circadian rhythms. So Dr. Kayla Rohr is joining us from as a postdoc working in Michael McCarthy's lab in the University of California, San Diego. Just as a little note, I'm going to ask that nobody share any of the information that is being presented by Kayla today. So with that, I'll hand that over to Kayla. Great, fantastic. Thank you so much. As I mentioned, guys, if you have questions for the speakers that have already been, feel free to pop it in the Q&A and they can comment from there. So with that, we will move on to our final speaker. Last but certainly not least, we have Abiola Saka from the University of Bristol. He is a third-year PhD student working in digital health and care and is interested in using AI and data analytics to try and understand the mechanistic link between sleep, cognition, and psychosis in adolescence. So with that, I'll pass it along to our final speaker. Who I think might have frozen. You there?
Yeah, my network froze.
Okay, sorry, I was just introducing you. You're more than welcome now to share your presentation and you can get started.
Okay. Okay. Good afternoon, everyone. Thanks, Ami, for having me, and to all everyone present here. So my name is Saka Abiola, and I'll be presenting my PhD work, which is ongoing on the interplay between cognitive deficit and the risk of psychosis, the role of sleep. Convergent evidence implicates sleep in modulating cognitive deficit and the psychosis risk across lifespan, but precisely when and how sleep matters remain unclear. So our central hypothesis is that people with disrupted sleep and circadian rhythms early in life are more likely to develop psychiatric problems, including psychosis. But to test this hypothesis, there are some basic problems. And the first one is that there is need to have longitudinal assessment of sleep and circadian rhythm. And also, it is necessary to have the right population for a viable experimental design. Copy number variants are mutations where people are missing small sections of DNA, which could be in fact as much as 1.5 megabytes of genetic information, or have extra copies of these sections of DNA. And 22q deletion syndrome occurs in 1 in 2,000 births. And this is very vital in this context because while ADHD, anxiety, and cognitive deficits are common at the early stage of 22q carrier, about 40%. I'm trying to get my pointer. Okay. So about 40% of adults diagnosed with 22q deletion syndrome will be diagnosed with schizophrenia later in life. So the main question is, what's happening to sleep and circadian rhythm in this population? And that's what the Sleep Detective hopes to find out. So Sleep Detective is a co-design project looking at sleep stratification in young people at high risk of psychosis, with the primary aim of developing robust, objective, longitudinal measure of sleep and cognitive function in children with CNV22q which are associated with neurodevelopmental disorders like ADHD, anxiety, like as I've mentioned earlier, and also adulthood psychiatric symptoms. So the next question is, how then do we measure sleep? Previous study with 22q and unaffected sleeping as controls identified restless sleep and insomnia as the major two patterns of sleep in this population using parent-reported questionnaire, but this rely on subjective perception of sleep, which is often flawed with recall bias and also has limitation in terms of the kind of information we can get regarding sleep. The next step was then to carry out a cross-sectional design using a one-night high-density EEG, where mediation analysis indicated that 22q effects on anxiety, ADHD, and autism spectrum disorder were partly mediated by sleep EEG measures. Of course, YPSG is very accurate and well validated, and it is in fact like the gold standard for sleep measure. It is very costly in terms of setup, and also it is not scalable and invasive. We also did actigraphy, and have in initial stages of my PhD compared those questionnaires with actigraphy. And also I derived rest activity readings, which is essentially a proxy to circadian readings. So we derived acrophase amplitude and measure from the actigraphy data. So two key methodological findings were gotten from that study. And one is that there was moderate agreement in time in bed between diary and actigraphy. And also we saw some potential utilities of RAR metrics, acrophase and meso, especially in sleep quality assessments. So longitudinal studies afford opportunities for early detection, early intervention, and mechanistic insight into the relationship between sleep, cognition, and psychosis. But then the problem here is traditional PSG, as I've mentioned earlier, is not feasible for longitudinal studies because of the setup, the invasiveness. And that's where portable EEG headbands and Fitbit tracker comes into rescue. But certainly that also comes at a cost. While Fitbit and EEG headbands are relatively cheaper and they are scalable, they are very good, they are easy to use, and they present minimal user's burden. Their accuracy cannot be compared with, EEG, high density EEG or full PSG, and that is where the problem lies. So it's the same case with actigraphy as well. Fitbit, of course, is very usable among participants, but the main problem is that it is not scalable. So Sleep Detective, as I mentioned earlier, is a co-designed study looking at sleep stratification. And in fact, those two pictures were some of the sections at the PPI section that we had. And aside the PPI section, we also have a well-formed patients advisory group comprising of young adolescents with lived experiences and other important stakeholders. But my main point of today's talk is about extending what we've already done into developing longitudinal approach. Of course, we know based on the questionnaire measures that these kids have sleep problems very early on. But then how do we convert from that subjective measure to objective quantifiable metrics that include some neurobiological insights? Well, we layer actigraphy data on EEG onto those questionnaires, and my PhD is about understanding how those thoughts about integrating across these different modalities can give us toolkits that can then be used in longitudinal assessing sleep health in 22q population. So it goes from establishing some methodological insights using some existing data within that population to validating the utility of those portable EEG devices and Fitbit tracker using pilot data from a typical developing young adult. Then finally, to applying those validated tools in clinical context, in this case, in the 22Q population, and of course, their siblings to be used as a control group. So the next step in my study is then to validate those methodology. So we'll start by looking at the objective and subjective metric concordance in terms of looking at how measures from sleep diary compares with Muse and Fitbit. Then we'll then go ahead to validate the rest activity metrics, the acrophase, the amplitude, the measure using Fitbit, just like we have done using actigraphy. Most especially because the way actigraphy works is not directly how Fitbit works. Then we'll validate the Fitbit itself, looking at how useful it is, and hopefully while doing that, we'll address some of the potential problems that so many studies have reported regarding using Fitbit, in the sense of overestimating the total sleep time and total time in bed, and underestimating wake after sleep onset and sleep onset latency, thereby leading to skyrocket value for sleep efficiency. And a potential way of achieving this is, rather than limiting ourselves to the out-of-the-box metrics from Fitbit devices, we will utilize the intradaily data from Fitbit by plugging in via API. And we intend to use the raw activity count with the heart rate in actually characterizing these sleep metrics. We then go ahead to validate the Muse headband, because that's one of the problems with some of these portable EEG devices. Most of them have not been validated in adolescent population. But the first step in achieving that is that we will establish if the EEG hardware itself is giving us the required quality of data that we require. Then we then compare the out-of-the-box Muse sleep scoring algorithm with others. So lastly, we'll compare Fitbit with Muse in terms of seeing how close the measures from the two devices are. So we use several analysis techniques like epoch by epoch analysis, whereby we compare minute by minute data from these two devices to see the sensitivity and specificity. We also use linear mixed model concordance analysis. Okay. So this is the outlook of the proposed toolkit architecture. They've been intentionally designed in this modular form to reflect the reality of, the PhD studies, because even picking each of these, there are so many methodological bottlenecks that could be addressed. So it's been designed in this incremental approach to give, for us to actually see how we can achieve this. So even looking at the data integration and the processing aspect alone, there are so many methodological bottlenecks that has been reported in many studies, starting from the data heterogeneity, the sleep data that we want to combine are of different nature, and also the longitudinal data complexity. How are we going to map participant data across several time points where data will be collected, up to data quality and cleaning, privacy, and ethical consideration. So these are some of the methodological problems that we intend to solve with the toolkit. So in conclusion, some of the key takeaways from this discussion is, one, early life sleep and circadian disruptions correlate with psychiatric risk, including psychosis, and the copy number variant, especially in 22q, provide a unique lens to studying this association. And also, a robust, ethical, and scalable toolkit is very vital for longitudinal assessment of sleep health in this population, and which is, in fact, a right step towards achieving precision psychiatry. Thank you for listening.
Thank you so much for a fantastic talk. That was really interesting. That came very quite nicely in full circle from the beginning of our speakers, Catia talking about early life and sleep, as well as Raahat's co-production and co-designing and research as well. So it's come all nicely full circle. Does anybody have any questions for our final speaker? I'll let you have a little think. Feel free to raise hands as well. So I'll ask a question more so from the kind of Circadian Mental Health Network perspective of things. We are extremely interested, obviously, in the involvement of lived experience individuals as well as open data science. Are you eventually going to be kind of sharing your process of how you created this toolkit and how you got over some of these methodology issues that you've described?
Yeah, sure. We intend to make everything that we'll be using in this study open source so that it can contribute widely to the scientific network.
Fantastic. I think everybody's quite excited to hear that. Do we have any other questions for our final speaker?
Thank you.
Great, fantastic. So thank you so much to everyone who has spoken today. We've got a couple of minutes, so if anybody has any burning questions for any of our speakers today, please feel free to raise a hand, pop it in the chat or the Q&A. But I would just like to say thank you so much to all of our speakers for joining us and giving us your absolutely fantastic talks. I feel like we've got such a breadth of what is happening across the network, as well as at all of these different kind of career stages and different things that you guys are doing, which has been amazing. I'm not seeing anybody rushing to put their hands up. I think everybody's trying to absorb everything that has been said for today. So again, thank you so much for your fantastic presentations, and thank you so much to everyone who has joined us today. I know you've all been joining us from across the world, and I really appreciate you all making the effort to be here. This session has been recorded, and the majority of today's webinar will be shared eventually on the network YouTube channel as well. If you're not part of our mailing list, I'll be popping a little question out to you guys soon that have joined us today to see if you want to keep in touch with everything else that's happening with the network. So with that, I will thank all of our speakers once again, and thank you all for joining us. We had some amazing talks today, and hopefully we'll be having many more of these ECR webinars in the future. So thank you all for joining us today. Goodbye.